The universe is vast. So vast, in fact, that even calling it unfathomable doesn't quite do it justice. We live in a galaxy, our Milky Way, among billions of others, all drifting silently across a canvas so large it defies imagination. For a long time, astronomers thought these galaxies were just coasting through space, moving in whatever direction they began after the Big Bang. But then, something strange happened. In 2008, astronomers noticed something deeply unsettling. Using data from NASA's Chandra X-ray Observatory, they were studying clusters of galaxies, the largest structures in the universe bound by gravity, and they noticed that many of them weren't just moving randomly. Number. They were drifting, together, in the same direction. Not slowly either. They were accelerating, racing at nearly 2 million miles per hour toward a specific region of space. But here's the problem. That region is completely black. Nothing is there. Nothing we can see anyway. This wasn't just a minor observation buried in a technical paper. This had the power to upend everything we thought we knew about the universe. Because galaxies aren't supposed to do that. They're supposed to scatter, pulled subtly by the gravitational tugs of nearby matter, stars, clusters, superclusters. But this looked like something else entirely. It was as if something massive was pulling on our entire region of the observable universe from beyond the darkness. Scientists called it dark flow. Let that name sink in. Dark flow. It's a term that sounds like science fiction, but it's real. And what it implies is even more terrifying. The discovery of dark flow came from analyzing the cosmic microwave background radiation, the faint afterglow of the Big Bang itself. By studying tiny distortions in this background caused by the motion of galaxy clusters, scientists could trace how these clusters were moving through space, and what they found sent chills down their spines. The galaxy clusters, dozens of them spread across billions of light years, were all headed in the same direction, like iron filings drawn toward a hidden magnet. That direction, somewhere near the constellation Centaurus. But when astronomers looked there with the most sensitive telescopes humanity has, they saw nothing but emptiness. No galaxies, no superclusters, not even dark matter. Just void. It was like watching a school of fish swim toward an ocean trench, only to vanish into blackness. What could possibly be pulling entire clusters of galaxies? What kind of structure, what kind of force could influence matter on that scale? Some scientists proposed an idea that sounds impossible. What if this force wasn't in our universe at all? What if it was coming from beyond, from another universe entirely? If that sounds like science fiction, you're not alone. The suggestion that some other universe is tugging on our own seems outrageous. But mathematically, it can't be ruled out. In fact, some versions of string theory, the most ambitious attempt to unify all the forces of physics, predict that multiple universes might exist, each with their own rules, separated like bubbles in a vast cosmic foam. And in that framework, something could be leaking in, a gravitational pull from a neighboring universe, reaching across the cosmic boundary like a ghostly hand. This idea lit the scientific world on fire, not because it was proven, but because it couldn't be dismissed. The data was solid. The movement was real. Something was out there, and we had no idea what it was. To make matters even stranger, the area toward which all this dark flow was heading, this blank spot on the map, was already known to scientists. It's part of what's called the CMB cold spot, a large, unusually cool region in the microwave background that has defied explanation since it was discovered. Some thought it was just a statistical fluke. Others wondered if it might be a sign of something even stranger, like a collision between our universe and another. Now, suddenly, galaxies were moving toward it. It's hard to overstate how deeply this shook cosmology. Because if this was true, if something outside our observable universe was influencing us, it would mean our universe isn't closed. It would mean the Big Bang wasn't the beginning of everything, just the beginning of our pocket of reality, a single droplet in an unfathomably vast multiverse. And that's when things started to get even weirder. Because in 2010, new data showed that the dark flow wasn't weakening. It wasn't slowing down. In fact, more galaxy clusters were being caught in its grip. The direction stayed the same, the speed increasing. This wasn't just a one-time anomaly. It was a consistent, large-scale drift across the cosmos. Imagine standing on a beach and seeing a tide pull boats away from the shore, not just a few, but thousands of them, toward a stretch of ocean with no visible current. That's what this felt like, an invisible force dragging everything toward the void, and we, our solar system, our Milky Way galaxy, all of us, are caught in it. No one knows where it leads. No one knows why it's happening, and no one can stop it. But maybe, just maybe, it's trying to tell us something. Maybe it's the first whisper of a deeper truth, that our universe is not alone, that somewhere out there, beyond the darkness, something else exists, something that is aware of us, and pulling. After the initial shock of discovering dark flow, scientists did what they always do. They tried to explain it. Maybe it wasn't something exotic after all. Maybe the universe wasn't being pulled by a hidden monster behind the curtain. Maybe, just maybe, it was something closer to home, something simpler. That's when the idea of cosmic voids came in. A cosmic void is, quite literally, a vast emptiness in space. Unlike the popular image of space being filled with stars and galaxies, most of it is actually empty. But some regions, these voids, are so empty they're like deserts inside deserts. And just like gravity pulls things inward, these voids might have a sort of anti-pull. Not because they push, but because the surrounding denser regions tug harder, drawing matter away from the emptiness. That's how gravity works. It's not about being pushed, but being pulled from the denser side. So, could these voids be behind the dark flow? A team of researchers in 2017 thought so. They proposed that what looks like a mysterious pull from beyond might just be the result of our Milky Way being surrounded by underdense regions, voids that distort our measurements of movement. Like a boat drifting in a current it can't see, we might just be floating along a cosmic tide created by local imbalances in the universe's structure. This idea offered comfort. It said, hey, don't worry, there's nothing out there pulling us from beyond the universe. It's just gravity doing its thing. But not everyone was convinced. The biggest problem, the flow was too fast, too large, too consistent. The sheer number of galaxy clusters moving together over vast distances couldn't be explained just by nearby voids. The gravitational forces required to pull entire swaths of the observable universe in the same direction were astronomical, and they seemed to originate from a part of the sky where nothing should exist. So, if it wasn't voids and it wasn't an illusion, then what? That's when scientists started considering the most mind-bending idea of all, the multiverse. Now, the multiverse isn't just science fiction. It's actually a serious concept in modern physics. According to certain models of inflation, particularly eternal inflation, our universe is just one bubble in an ocean of others. When the Big Bang happened, it didn't just create our universe. It created a chain reaction. Countless other bubbles could have formed, each with their own laws of physics, expanding forever in a cosmic froth. In this view, dark flow might not be a mystery at all. It might be evidence. Evidence that another bubble, another universe, is close enough to pull on ours gravitationally. Maybe it formed earlier. Maybe it's larger. Maybe its physics allow it to exert far more influence than ours. And maybe, just maybe, It's reaching across the boundary. Think of two soap bubbles floating next to each other. If one's surface touches the other, they distort, influence, and sometimes merge. If the same thing is happening on a cosmic scale, dark flow could be the bruise left by that contact. Physicist Laura Mersini-Houghton even took this further. She proposed that the cold spot in the cosmic microwave background, remember that unusually cool patch of space, wasn't just a random fluke. It was the scar of a collision, a crash between our universe and another, not visible with telescopes, not audible with radio waves, but imprinted in the oldest light of all. If she's right, dark flow and the cold spot are part of the same story, not just signs of a hidden force, but signs of another universe. It's a theory that raises as many questions as it answers. If another universe is pulling us, what does that mean for our future? Will the two collide? Will they merge? Is the other universe inhabited? Are we drifting towards something intelligent or just another blind pocket of matter? We may never know. Because here's the twist. We can't see beyond our cosmic horizon. The observable universe is limited by the speed of light. We can only see light that's had time to reach us since the Big Bang, about 13.8 billion years ago. Anything beyond that, hidden behind a wall we can't look through. If something lies beyond, it's invisible, undetectable, unless it affects us in some indirect way. And dark flow might be that indirect signal, a subtle tug from across the curtain, a whisper in a language we don't yet understand. Of course, not all scientists agree. Some still believe the measurements of dark flow are flawed, that cosmic background radiation is trickier than we think, that there's no mysterious force, no multiverse, no need to rewrite the laws of reality. But here's what we do know. Something is happening. Galaxy clusters, huge gravitationally bound families of galaxies, are moving in unison across enormous distances, and no known structure in the observable universe can account for that. Not even the Great Attractor, the massive gravitational anomaly pulling galaxies in our local neighborhood, comes close to explaining the scale and direction of this drift. And in science, when you rule out the known, you're left with the unknown. Maybe that's where we are now, on the edge of understanding, caught between the comfort of what we can see and the haunting implications of what we can't. Because whether it's a hidden superstructure, a gravitational ghost, or the influence of another universe entirely, one thing is clear. Our galaxy is not moving aimlessly through space. It's being pulled, and whatever lies at the other end of that pull has yet to reveal itself. As we stand on this cosmic shore, looking out into the vast ocean of the unknown, the question remains, what happens next? If our Milky Way is being pulled by something beyond our observable universe, what does that mean for us, for our galaxy, for everything we know? First, let's consider the scale. We're talking about motion at hundreds of kilometers per second. That's faster than the speed of a commercial jet, but in cosmic terms, it's a slow drift, taking billions of years to cross millions of light years. So, there's no immediate danger of being pulled into a collision or disappearing into a cosmic abyss tomorrow. Not that kind of urgency. The universe moves on its own, majestic timeline. But this mysterious push or pull hints at something much deeper, a reality that might be stranger than any science fiction story. One possibility is that the dark flow is a sign that the universe is not uniform. Since the Big Bang, cosmologists have assumed that on large scales, the universe is the same in every direction. Homogeneous and isotropic? This principle underpins much of modern cosmology. But what if it's not true? What if our patch of the cosmos is unique? What if hidden structures or forces outside our horizon are influencing our cosmic neighborhood? If that's the case, it challenges the foundation of cosmology and forces scientists to rethink how the universe began, evolved, and how it might end. Another implication is that the mysterious force could be evidence of multiverse interaction, other universes touching ours. This concept pushes science into new territory where physics meets philosophy and even metaphysics. What does it mean if we are one bubble among many? If universes collide and merge, or if their boundaries shift, would the laws of physics be rewritten? Would time itself change? On a more practical level, the mysterious force pulling us could affect the future of our galaxy. Over billions of years, gravitational forces shape galaxy clusters, influence star formation, and even steer cosmic collisions that create new structures. If the dark flow leads our galaxy toward a massive unseen mass or another universe, the cosmic environment we live in could transform drastically over eons. It might trigger starbursts, black hole activity, or even alter the path of the local group of galaxies. For humanity, the cosmic push is a reminder of how small and connected we are. Our Earth, our Sun, our galaxy, they're part of a grand dance, influenced by unseen forces far beyond our comprehension. And as we explore the cosmos with better telescopes, more powerful satellites, and advanced simulations, we edge closer to understanding these mysteries. One day, maybe we'll develop technology capable of detecting what's beyond the cosmic horizon. Maybe future generations will witness the interaction of universes or map the invisible structures pulling on our galaxy. Or perhaps this mysterious force is a call to humility, telling us that no matter how far we look or how much we learn, there will always be mysteries beyond the veil, waiting to push and pull us toward new horizons. In the end, the universe is a vast, living tapestry. Dark flow is one of its most mysterious threads, weaving a story of connection, motion, and the unknown. And as long as we keep watching the skies, listening to the whispers of the cosmos, we'll keep moving forward, toward answers, toward discovery, toward the endless frontier. Because the universe isn't just out there, it's also inside us, a force pushing us to explore, to question, and to dream. And maybe, just maybe, one day we'll understand what's really pulling us through the darkness.